Good day, students and viewers. You are welcome to the studios of Maths X. In our previous video, we introduced the topic number-based systems. Number-based systems. In that video, we defined what number-based systems are, and we did not just do that. We also talked about the four most widely used number-based systems in mathematics, and that is the binary, the decimal number system, the octal number system, and the hexadecimal number systems. We also talked about their uses in mathematics. In that video, I also exposed you to the word radix, though not commonly used, but also a legit way of expressing the word base. In today's video, we're going to go deeper into what we already started. In today's video, we'll talk about how to convert numbers from base 10 to other bases and from other bases to base 10. But as it is our culture, just before we begin our presentation for today, we are going to recognize our subscribers for the week. And we want to say thank you so much for doing what you've done. You've given us a lot of value. God bless you. Being done with that, let us begin. So for the first part of today's class, we're going to convert numbers in base 10 to other bases. So for our first example of converting numbers in base 10 to other bases, we have it here that convert 26 base 10 to a number in base 7. To do this, there is something we call the continuous division method. It's very simple. All you need to do is to be properly acquainted with your times table. And not just that, we also need to observe our remainders when we do these divisions. Yes, these continuous divisions, as we do them, we are mindful of our remainders. That's why I'm emphasizing that all we need to do to be able to get this done is to be properly acquainted with our times table. Anybody that has a good grasp of his or her timetable should not have a problem doing this particular exercise. And this is how it's done. I will take most space on this side of my board. So here we go. We're supposed to convert 26 base 10 to a number in base 7. In our previous class, I told you that the biggest notation in base 7 will be a 6. I'm sure in that video you must have observed how I called out numbers in base 4, numbers in base 5. I didn't call them in hundreds. I took time to call the individual numbers, recognizing the fact that this is not in base 10, because it is in base 10 you're having those kind of call outs, hundreds, in thousands, 343. You don't call it that way in base 5 or base 4. You would call it 343. 343. You don't call it 343 in base 5. You call it 343. So you did observe what I did, and I'll still be observing that here. So in base 10, in base 7, definitely the highest integer is gonna be 6. It cannot be more than that. So here we go. For our continuous division method, we're gonna have a 2 and 6, that's 26. You rule a line, and we have our 7 as your divisor. You will also observe another line here where you have your remainder, where you place your remainders, because these remainders will be of good value to you at the end of your operation. So 7 into 26, 7 into 26 is 3 times, right, which is 21. Remainder what? 5. 7 into 3 cannot, so you have a 0. What is your remainder? You have what? A 3. So to get your value right, you will call the numbers or write the numbers from downside up. You've seen my arrow. So in conclusion, 26 base 10 is actually 3, 5 base 7. It's just this simple. It's just this simple. And like I said, you need to be very acquainted with your times table. For our second example today, it says convert 33 base 10 to A base 4, B base 6. I'll take it again. Convert 33 base 10 to A base 4 and B base 6. So here we go. We're still going to be using our continuous division method. So like I said earlier, the base I'm going to use is my divisor. So we're going to have a 4 here, and then the base 10, which is 33, and then keep place for our remainders. So here we go. 4 into 33 is 8 times, which is 32. Remainder 1. 4 into 8, 2 times. Remainder 0. So that's your 2 and your 0. Of course, 4 into 2 cannot. You have a 0. What is your remainder? 2. So you have a 2 here. And like I did earlier, watch, that's my arrow. You call the number from down up. So 33 base 10 is equal to 201 base 4. Notice I did not call it 201. I talked about this in our previous video. I explained this. So I'm not calling it 201 because this is not in base 10. It is 201 base 4. Let's do the second one. This is for the A part. For the B part, also base 6. So your base 6, which is your divisor, 6, which is your divisor, and we have 33 and R as your remainder. So 6 into 33. 6 into 33 is 5 times, which is 30. 6 into 33 is 5 times, which is 30. So we have a 5 here, remainder 3. 6 into 5 cannot. We have a 0. And what is our remainder? Our remainder is what? 5. So that's how we call it. So 33 base 10 is actually 53 base 6. So for our next set of examples, I'm in this example convert 129 base 10 to base 4 and base 8. So I'll start with the base 4 first. So for 129 base 4, let's start with the A part. So we have our divisor, which is a 4. We have 129, which is to be converted, and then place for our remainders. So here we go. 4 into 12 is 3 times. 4 into 9 is 2 times. Remainder 1. Still using 4 again. 4 into 32 is 8 times. What's our remainder? We have a 0. We have a 0. 4 into 8, 2 times. What's our remainder? Another 0. 4 into 2 cannot. That's a 0. What's our remainder? A 2. And like we did earlier, we call it from downside up. So 129 base 10 is equal to 2001 base 4. This time around, we had to increase it. Earlier we were using 2-digit numbers. Now we've made it 3. So that's what we are having. And also in base 4, we are having a 4-digit number. That is 2001 base 4. Let's try the second one, the B part, which is the same 129 base 8 being our divisor. And then we have our remainder, R. 8 into 129. So 8 into 128 is 16 times. Remainder 1. 8 into 16. 8 into 16 is 2 times. Remainder 0. 8 again. 8 into 2 cannot. Remainder 2. So this is what it is. So our 129 base 10 is equal to 201 base 8. Please, writing the 8 in words is a choice. I explained this in our previous video. I could choose to also write it in figures. It doesn't make it wrong. For this next example, we are going to still convert numbers from base 10 to other bases, all right. But I decided to make it a bit, just put some complication into it a little. Now, earlier we used 2-digit numbers in base 10 to convert to base 4, base 6, and base 8, like I've done here. Then here I used a 3-digit number. But this time around, I decided to use a decimal fraction here. So I have 25.0625 base 10, and I want to convert this number to binary. In our previous video, I explained what binary is. Of course, base 8 is the octal number system. So we put all these things through. So if you had not watched our previous video, you would do well to go back and check that particular video. It will do you a lot of good. Okay, so this is what we have here now, 25.0625 base 10 to be converted to binary. Binary is base 2. I discussed all that in our previous video. So I'll need some space. I have to take these things off. For this particular mathematical operation, the first thing we should do is to split the numbers. Yes, split the numbers, because we're going to work on the numbers independent of each other, as in the whole number side and the decimal side. So we have here that this number, of course, we should know is actually 25 plus 0.0625. So I'm going to work on the whole number side first. Doing that, we're going to do just the same operations we've been doing earlier, which is our continuous division. So, and I will do that for only the 25. And then afterwards, you will see what I will do to the 0.625. So for our 25, which is a very familiar operation, that will be our 25. Our divisor is definitely 2. Then, of course, we give place to our what? Remainder. So here we go. 2 into 2, 1. 2 into 5, 2. Remainder 1. If you watch, all what I'm doing is because I'm acquainted with my times table. That's why I insist that any student taking on this doing this particular mathematical operation should be very acquainted with his times table. So 2 into 1, I said 2 into 2 is 1. 2 into 5 is a 2. We have a remainder of 1. We have a 2, still using 2. 2 into 12 is 6, remainder 0. 2 into 6 is 3, remainder 0. 2 into 3 is 1, remainder 1. 2 into 1 is 0, remainder 1. And that's our count. Let me place it on this side so that our 25 base 10, I'll put it in number system, I told you it's not wrong, will be 1, 1, 0, 0, 1 base 2. Now that we are done with the whole number part of this particular exercise, we will go into the decimal fraction part of this exercise. To do that, we're going to make a table. So we have 0, 6, 2, 5, pull a table, and this is our point, times 2. We are going to continuously multiply by 2 since we are converting this number in base 10 to base 2. Then every leftover, we'll put it on this part of our table. What I mean is every carryover beyond the decimal point will drop here. Those are the leftovers. So we have 2 times 5 is 0, carry 1. 2 times 2 is 4, plus that 1, we have a 5. 2 times 6 is 12. That is 2, carry 1. 2 times 0 is 0, plus that 1. We have 1. Any leftover? No, so we have a 0 here. Again, multiply, times 2. 2 times 0 is 0. 2 times 5 is another 0, carry 1. 2 times 2 is 4, plus that 1, 5. 2 times 2 is 2. Any leftover? No, so we have a 0 here again. Times 2. Again, we keep multiplying till it ends. 2 times 0 is 0. 2 times 0 is another 0. 2 times 5 is a 10, that is a 0, carry 1. 2 times 2 is a 4, plus that 1, 5. Leftovers, 0, nothing is remaining. Again, times 2. 2 times 0 is a 0. 2 times 0 is another 0. 2 times 0 is a 0. 2 times 5 is a 10. So we have a 0 here, and there's a leftover this time around. So we have what? 1. As you can see, the maths, as in if you keep on multiplying, we'll have nothing, clearly, because these are all zeros. And to pick up these numbers, here we went up, right? Look at my arrow, I went up. Here, I'm going down. So my 0.0625 base 10 is equal to 0.0001 base 2. So putting everything together, that my 25.0625 base 10, because of space I'm using numbers. Hope if you see my base, I'm making it truly a subscript, will be equal to, pick from here, that is 11001.0001 base 2. My dear students and viewers, I'm sure you've seen what I have done. For today's video, I have converted numbers in base 10 to another base by a method of continuous division. But however, when I came into the decimal fraction part, it looks like a continuous multiplication. But I'm sure you've seen what I have done. I trust you have learned how to do these conversions. In our next video, we will be converting numbers in other bases to base 10. Till we meet again, my dear students and viewers, I want to say keep watching the videos of Maths X, like, share, and subscribe. As you do so, God bless you real good. Thank you.